Hello, everyone. You are welcome to today's lesson. And in today's lesson, it's going to be a very short one. Our task here is to look at the solution that was given in lesson one of rational functions and partial fractions. So this was the assignment, right? The partial fraction identity of. So immediately you read the question and you see identity. So it means don't go beyond the identity. Going beyond the identity means you go on to find the letters, introduced in your identity. So here, just give us the identity. And some of you went as far, I don't know whether you wanted to flex your muscles because you've done partial fractions. And I remember very well that in the video I told you that when identity is an identity, when you are asked to find the identity, underline the identities, it means don't go beyond, don't find the values of the unknown and get us the exact partial fractions. Immediately you do that, then you have rather resolved the rational function that you are giving there into partial fraction. But here you were not asked to resolve, you were just asked to write the identity. First of all, you have to be very strong with your identity before you can resolve. So I'm going to spend time on the identities. If your identities are perfect, going forward, the work will be very easy. So quickly, let me go straight to the point. So as usual, after reading the question, underlining the salient parts, the first thing that you write is solution. After solution, you extract, what you will need to find whatever that, or what you are provided to find whatever that you are supposed to find. So in this case, given, then you extract this, or you can ignore the given, but this must be extracted. Now remember, I told you before in lesson one, I told that before you can write the identity, straight away write the identity. The very first question you need to ask yourself, is anytime you are writing the identity, what did I say should be the first question you should ask yourself? What did I say? Prof. Inshira.
She said we have to check if it's proper or improper.
Perfect. Perfect. So proper or improper. So in this case, let's check, let's verify. What's the degree of the numerator? The whole class. What's the degree of the numerator? As for degrees, we should be experts by now.
These two.
2. What about that of the denominator?
4.
4. And we all know that 2 over 4 is what? A proper fraction. So on that note, it means it's proper. Once it's proper, the next question or our next point of call should be the denominator. So you go and check the denominator factors. If any of them is factorable, you factorize. So take note of that. So if you look at the denominator factors, the first factor that you have here, which is 4 minus s squared, the denominator has 2 factors, 4 minus s squared and this factor 2s squared minus 3s plus 1. This 4 minus s squared is factorable. Obviously, you can see difference of two numbers, where the second, number, though it contains a variable, or difference of two quantities. The second quantity, you can see that it's obviously a square of a quantity x. But it's the first quantity that is not obviously a square, but we all know that 4 is a square number. So 4 is 2 squared. Do you agree?
Yes.
So on that note, we can clearly see that this is difference of 2 squares. And if at this level we don't know how to factorize difference of 2 squares, then it means there is more room for improvement. So this factor here is factorable. However, this factor that we have here, once it's difference of 2 squares, that factorization I can factorize straight away. Meaning just a step, I can end what's the factorization, because I know that this is 2 squared. So what I have there, let me quickly write that. So I'm coming. Why is my, not working? Give me some few seconds. Oops, I can't see. I think it has. So this is it. So what you have here, your 4, minus x squared. We all know it's the same as what? 2 squared minus x squared. So now obviously, difference of 2 squared. We all know that if you have a squared minus b squared. This one factorizes into a plus b as one factor, then a minus b as the other factor. So in this case, your a is 2, your b is x. So it will be 2 plus x as one factor, then 2 minus x as another factor. Is my point well made, my professors?
Yes, please.
Okay, but if you are matured, immediately you see that this is 2 squared, okay, minus s squared. Straight away, you know that 2 plus x, 2 minus x. So you can factorize this one just by a step. So it means you can choose not to do the rough work for this one. But this one you cannot factorize, it's factorable. You cannot factorize just by a step. You can only factorize just by a step when it's a special situation where your leading coefficient, which the coefficient of s squared is 1. But unfortunately, it's not 1. So we have to go through factorization by grouping. And we all know 2s squared minus 3s plus 1. You multiply the 2 and 1, which will give you 2. Factors of 2, factor pair, that you multiply, you get 2. When you add, you get negative 3. And that will be negative 2, negative 1. So you use that one to split. Okay, then you group first 2 factorize, last 2 factorize, and so you import this result. So it will be equal to, your numerator will be intact, your denominator, write it in terms of all the factors. So your denominator must be factorized completely. So this one is factorized. This one is also factorized completely. So at this point that you know that your denominator factors, none of them is factorable, okay, you can think of writing the identity. Is my point well made? Okay, great. So on this note, okay, this is what we are supposed to have. Okay, you write your identity, and even at that point, you could have drawn your conclusion. At the point that you are going to write your identity, you could have written, okay, meaning this step here, you could have taken it out and concluded straight away, because you know that that step will give you the identity, and that's what we are looking for. So if you look at the linear factors in the denominator, how many factors do we have in the denominator? How many factors?
Is 4.
4. Originally it was 2, but each one factorized into 2, so 4. So once it's giving you 4 non-factorable, okay, linear denominators, it means your fractions, your partial fractions, you have 4 of them. 1 for each, okay, denominator factor. So ordinarily it would have been, okay, your denominator will be 2 plus x for the 1. Okay, the numerator, you can leave your numerator plus, okay, 2 minus s, then plus, okay, numerator there 2 minus 2x minus 1, then plus x minus 1. However, because the denominators are linear, remember, we said the numerator will be what? Will be a constant. So this will be constant a. This also should have been a, but if you use a, it means you are indirectly mathematically trying to say that, okay, these two numerators are the same, but they will not always be the same. So in that case, okay, you introduce a different letter. So it will be B, C, D, as I told you in this. So take note. Okay, so this will be the order. If your degree is 0, it is a constant. Okay, if your polynomial has a degree of 1, it's given a special name, linear polynomial. Okay, the degree is 2, quadratic polynomial. 3, cubic polynomial. 4, quartic, as in quarter, quartic. And 5 will be quintic. So you should know, immediately your denominator is linear, you go up. The numerator will be a constant. If your denominator is quadratic, you go up. Okay, the numerator will be linear. If your denominator is cubic, you go up. It means the numerator will be quadratic. And all of them, I'm talking about a situation where it is not factorable. Okay, if it's quadratic and it's not factorable, the numerator will be linear. If it's cubic and it's not factorable, the numerator will be quadratic. If it's quartic and it's not factorable, the numerator will be cubic. So always your numerator will be a degree lower than that of what the denominator. Is my point well made, my professors?
Yes, please.
Okay, and please take note. I think some of you have this idea. I don't know where you got it from. That's okay. If you have, anytime you are factorizing, there should always be a variable first. Okay, or maybe someone did this. So I was just trying to go into the person's head to see what's okay. If you write this one this way, okay, you know that this we said is the same as if you write it 2, okay, squared minus s squared is perfect. But this will factorize into, okay, 2, somebody can write minus x, Or let me write 2 plus x. And okay, the person also wrote what? 2, okay, sorry, x minus 2. The two are not the same. Please take note. As for the s plus 2, addition is commutative. So this result here is the same as this. However, okay, subtraction is not commutative. So 2 minus x here, this factor is not the same as that. So take note, if in your factorization, if the first one is a constant, in writing your first factor, the first, okay, term in the first factor should always be that constant that you raise to the power. Okay, take note. And I've told you, someone I think did this minus 2 plus x. That is okay, that is right. Okay, that is right. But you know, I've told you that anytime you have a negative and a positive, you write a positive first. So this you rather look, okay, like this. Okay, was it? No, was it this way? Yeah, no, was it this way? I think, did I see this? No, it was rather minus x, okay, plus what? Plus 2. I think this was it, how the person wrote it. Okay, and please, we know this is the same as this. What you have here is the same as this, but mathematically, okay, it's better you write a positive first. Okay, it's convenient so that it will be the same. Okay, Prof. Inshira, I guess you were the one, right?
Yes, please.
Okay, so that was the little problem with your presentation. You were the only one who came very close to what was expected of you. Okay, so it should have been, I think now you know, I think I've been saying it. Anytime you have a positive and a negative, even when we were doing the identities, I reiterated that point. You get it?
Yes, please.
Okay, it is always, okay, true for all situations. Okay, so any questions before I finally, okay, so if you factorize this as your rough work, then don't forget to strike this one out. Please take note. Okay, this one is already, okay, taken care of. So this one obviously will be a vital rough work. So you strike it out as well. Is my point well made, my professors? Okay, so we can end the class here. Okay, so thank you very much, okay, for your attention. God bless us all.